Hi guys, we're looking at the sine function today. So when we're drawing with trigonometric functions, we have different graphs that represent different trigonometric equations. So for instance, you have your sine graph, you have your cosine, and you have your tangent. Over the next few videos, you're going to be looking at those different types of different trigonometric functions and how changing certain parameters of the equation changes or alters the look of your graph. So let's get into the sine function today. So let's go back a little bit. We're going back and look at the unit circle. When it comes to the sine function, we get everything that we need from the unit circle in terms of how that graph itself looks. So if we look at the unit circle in its basic form, when we have quadrants 1, 2, 3, 4, and we have those 4 points. So we have 2 pi, pi on 2, pi, 3 pi on 2, and 2 pi again, or starting from 0 at the beginning. We can look at these points and say to ourselves, okay, well, if we're looking at radians, what do we notice for sine? If we come back up here, remember sine theta is equal to y, and cos theta is equal to x. So what we're looking here is at these 4 points, what is the y coordinate of sine at these exact points? So if we have a look at this graph over here, we can say at 0 radians, at the starting point here, sine is 0. So I can put a mark here. At pi on 2, sine is 1. So I'll put a mark here. At pi, sine again is 0. And then at 3 pi on 2, sine is -1. And then we get back to where we started, 2 pi, it's 0 again. So we've got some kind of periodic behavior happening. Now, periodic behavior is basically one full revolution of a graph. So in this case here, if we join the dots, we've got a graph that represents the sine function. So y is equal to sine x. And if we look at this really carefully, we can see how this corresponds with the unit circle. Everything that is greater than 1, which would be quadrant 1 and quadrant 2 for y, is above the x-axis. Everything that is less than 1, or quadrant 3 and quadrant 4, is below the x-axis. And what else do we notice here? Well, we notice that the values of the maximum and minimum points are equal to 1. Okay, that's probably not straight, but we can see that here the minimum and the maximum is always 1. Because we looked here, it's 1, 1, 0, 1, negative 0, then -1. So we have this kind of repetitious graph. Now there are some points on this graph that we can actually take note of in terms of what we understand about it. Well, from the x-axis, and we'll have a name for that in a second, the name of the line that separates your max and your min is what we call the principal axis. So basically everything is moving up or down from there. These two red lines represent what we call the amplitude. So we know that, and we'll call the red lines the amplitude. So how high, so how far from the principal axis, let's see if I can spell that correctly. Does the max and min move? So So how far from the principal axis does the maximum mean move? Now, one thing to keep in mind when we're looking at this here is that we don't say this here moves by 1 and this moves by -1. It's actually moving a distance of 1. So distance can't be negative. So therefore, a lot of the times, the value you have in front, so if you have something that looks like this, y is equal to negative sine x, this doesn't mean that we're moving just down -1. What this means is the inverse. So that means instead of starting above, you start below and reflect it. So for instance, if we had, and we'll do this in a different colour, let me get a different colour. If we did y is equal to negative sine x, then all we're doing here is doing the opposite to what we did before. We come down, up, and over. So the negative itself does not change the amplitude. It's the value. Now a lot of the times we write something that looks like this. Y is equal to A sine x, where A is your amplitude. And it's always going to be a positive number. Another thing, let me just get rid of this here. Another thing that comes into play when it comes to the trigonometric functions is something that we call a period. So the period is, and let's write this over here, the period is the distance that one cycle takes. So is one cycle from start to finish. From start to finish before repeating. So if I continue this on again, then I'd have 2 periods. But because I've only got 1 period here, this cycle for this here, and I'll do this in terms of, let's just do it up here. So the distance from here to here is 1 period. And in the case of sine, tan, and sine and cos, the period is equal to 2 pi. Okay? So what we know about the sine function here is that we know that the amplitude tells us how far up and down it moves from the principal axis, and it's always a positive number, and the period, 1 cycle, is 2 pi. Now, what we're going to look at in the next video is we're going to start looking at how we actually make changes to these equations and what they look like on the graph. See you then.